Bismillahirrahmanirrahim, dear students. Today we are going to study about linked lists. First, you have to keep in mind that there are in fact two basic types of usage of memory when we are required to store more than one values. First is array. Array is in fact a collection of contiguous memory locations, and the second one is linked list. In linked list, you don't need to store the values in contiguous memory locations. They can be separated, they can be scattered over the memory, but still you can access one value from the other. So how it is done we will learn today. And every other abstract data type, for example, it is list, it is stack, it is queue, it is tree, it is graph, they can be implemented by both of these. So in fact these are the basic implementations, and all the abstract data types can be implemented in the form of arrays as well as in the form of linked list. Each has its own advantage and disadvantage that we will discuss. So let's start about what is in fact this list abstract data structure. So we already have done implemented list abstract data structure in the form of arrays. So here we will tell you what list abstract data structure is, and what is its implementation in the form of linked lists. So by implementation we do not we are not concerned in fact with the implementation that is with respect to the language. So we are going to implement with respect of the algorithm, and we all know what is the difference between algorithm and the actual program that is written in some language. So what we mean by a list is a collection of some elements as we did in array. The most important concept related to this list is that of position. We have studied in detail about this position and indexing in arrays. In other words, we perceive that there is a first element in the list, there is a second, there is a third. So each element has its position in the list. So we consider a list to be a finite ordered sequence of data items known as elements, and don't get confused by this word ordered. It's not in fact sorting. Ordered means that there is an order of position 1, 2, 3. Actual values need not to be sorted, so that is something different. This is close to the mathematical concept of sequence. So in sequence, you indicate every element of the sequence by some number. That number is in fact with respect to some position. So for example, if the sequence is denoted by A, so you said A1 is in fact the element at first position, A2 at second, A3 at third, and AN at nth. So it is just like this. So ordered in this definition means that each element has a position in its set. So it doesn't mean the elements are sorted by in some ascending or descending order by value or by alphabets from A to Z or from Z to A. So that I have already explained it to you. Each list element must have some data type. So whenever we save some data, so that location or that slot must be associated with some data type. So although there is no conceptual objection to list whose elements have different data types in the application, if the application requires it, but here we are concerned only that every element in the list will have the same data type, just as an array. So we can extend this concept later on. So a list is said to be empty when it contains no elements, and the number of elements currently stored in the list is called the length of the list. In array, we have learned that array is basically static, so the length of list, if we implement it through array, is fixed. So but here it will be some different thing. The beginning of the list is called a head and the end of list is called tail, and we can perform some basic operation on a list. So a list should be able to grow and shrink in size as we insert or remove, or in other words delete elements, but we know that in array the size is fixed, so you are not able to grow or shrink. So we had another concept of dynamic array. So that in fact means that you have to create another static array and you will copy all the elements of the previous static array in the new static array, and hence you can say that, oh, we have got a dynamic array. So in fact the size is not growing or shrinking, but with the help of duplicating the array with a new size, or in other words, you create a new array with the size of your desire. Either you are going to grow or shrink, and you are copying the previous elements. So in this way we were able to grow or shrink the list. So just recall that. So we should be able to insert and remove elements from anywhere in the list. That we have also done in array. We will do it now in linked list. So we should be able to gain access to any element's value, either to read it or change it. Change means updation, and to read means to traverse. We must be able to create a list, or we must be able to clear, or in other words, reinitialize a list. So it is also convenient to access the next or previous element from the current one. So this is also something. These are some basic operations on list. So there are two standard approaches to implement list that I've already told you. First is the array based list. It has its own limitations, and the second is linked list. We have learned arrays, so we'll now learn what is linked list and what are its types, and how to perform the basic operations that we have discussed in the previous slide. So first, what is the need for linked list? So sometimes you need to store a list of elements in memory. For example, you need to store 3 elements that are in fact the elements of your to-do list. So you are writing an app to manage your to-do list. So you will want to store the to-dos as the list in memory. So let's store it in an array. So array is in fact a combination of locations that are continuous. For example, if this address is 1001, so this will be 1002, this will be 1003, if we consider that each contains only 1 byte, or the word size is 1. So using an array means all of your tasks are stored contiguously right next to each other in the memory. First one is you have to take brunch, then you have to play bocce. Bocce is a game played with balls, and then you have to take tea, and you just needed 3. So you declared an array of 3, and here it was. The 4th location is reserved for something else. So there is free memory in the RAM other than this, but there isn't any 4th location just after this location which stores T. So now suppose you want to add a 4th task, but you cannot add the task here because it's already been occupied. So you have to move to a new spot where these all 4 can fit. So in this case we need to ask our memory manager that please award us or locate a new memory location where there is room for 4 elements, and it will relocate it and then copy these 3 elements and will insert the 4th element. So you have to move our task there. So similarly, adding new elements to a list can be a very, very big pain. So if you are out of space and need to move to a new spot in memory every time, so adding a new item will be really slow. It will cost you. So one easy fix to this is to hold seats. Okay, now I need 3, but maybe in future I need 10. I need more. So I asked my memory manager to hold 10 spaces for me, to reserve these for me, whether I use it or not. Now initially we need 3, and if we need 4th, 5th, 6th, we do not have to move it. We don't have to reserve more memory. So you can add 10 items to your task without having to move. So this is a good workaround. Workaround means what you can say in Urdu, jugaad. Okay, you have done that, but there are other problems to this, that we may not need these extra slots. So it in fact a waste of memory. Or suppose you need more after some time, you need more than 10 spaces. What will you do? You have to do this step again. You have to relocate your data, you have to shift your data. So that is in fact the main problem with arrays that we discussed when we were studying arrays. So in linked list, this problem is going to be solved, because with linked list, just look at the picture. Branch is stored here, Boche is stored here, T is stored here. These are located in a scattered manner in memory. So each item stores the address of the next item in the list, and a bunch of random memory addresses are linked together just like this. For example, it says address is 1, it says 13, and its stored is located at position number 22. So initially we know what is the start of the list, and that is address number 1, branch. So the head of the list will be pointing towards this, and this slot doesn't only contain the value, it also contains the address of the next one. So it saves 13 with it, which is not shown here, and it means that you can access this value, and if you want to go to next value, it is at location number 13. And when we go to location number 13, it tells us that this is the value stored at location number 13, but next value is at location number 22. So with linked list, your items can be everywhere in memory. Each item stores the address of the next item in the list, and a bunch of random memory addresses are linked together. So I think you know what this means now. So first you go to the address, and it says the next can be found at 1, 2, 3, and when you go to address 1, 2, 3, it says the next can be found at 8, 4, 5, 8, 5, 6, whatever you know. So with linked list, we do not need to move our item even once. Now I told you that this one slot doesn't only contain the address, the value that is stored, it also contains the address. So it means this slot will be consuming in fact 2 slots of memory. This one slot is in fact it contains in it 2 slots of memory. So a linked list is a sequence of data structures which are connected together via links, and each link, let's say it a node, contains the connection to other link, and you know these are controlled by pointers in C and C++ and in Java. So it is not just the actual value that is stored, we also store the address of the next location. So let's call this location as node, which contains 2 parts, actual data and the pointer to the next node. So I hope you understand how it is carried out now. So now it can be visualized as a chain of nodes, where every node points to the next node. So this is the first element, and there is a pointer pointing to it. So to indicate that this is the first one, it is called head. So this is the first element, it points to the second element, and then the second one points to the third element, and the third one points to nothing. So it means it is the end of the list. So these are actually 3 nodes here. Head is pointing to towards the first node, and the last node points to nothing, or in other words null, indicating the end of list. Now these are the following operations that we performed when we were studying arrays, and the same operation can be performed on the linked list. We can search for any node in the list, and in other words we can traverse every item, we can reach every item, we have the access to every item, and we can update any value, we can insert any value, and there are 4 cases. We can insert when initially the list is empty, so it means we are going to create the first node, or if we have some nodes, then we are going to create create a node or insert a node in front of the list, or you can say in the middle of the list or at the end. And similarly we can delete the last node, the first node, the middle node, anything. So we'll go through the algorithms of all these operations, and we will see how it happens. So searching a value, so we have already discussed in the previous lecture that we can search by many methods, but the 2 very basic methods are sequential search and binary search. In linked list we can only do sequential search. Why? Because in arrays we have the access to every element just by index. It's the compiler's job to calculate the address, but here we are controlling the address, and we don't know the index of anything. We just know where the head is pointing. We just know about the first one. We don't know how many elements are there in the list, because the third element cannot be accessed by first element. Only the next element can be accessed, and the next one has just access to the next one only, not to the others. So and in binary search we need to know what total elements are and what is the middle value, and that can only be controlled by index, and indexes are only present in arrays. We have no indexing type of scenario in these linked lists, so we can only do sequential search here. So everything has some pros and cons, so this can be considered as a disadvantage, but we will consider it when we will solve this problem, and we will study hash tables. So it's a combination of arrays and list. So this is not in fact a random data structure linked list. This is a sequential data structure, just like a tape. Now searching a value. So how can you search a value? You first have to know what is the first value, that is the head. It must not, it is not necessary to be included as an argument. The only argument that is required here, that is necessary, is the key, and the key is that value that you are going to search. Now how will this algorithm work? You will say current node is head. It means this current node is in fact the pointer that is pointing to the same node to which the head is pointing, and it will be node to navigate through. It will be used to navigate through the atoms, and we will discuss how it will use. And we also want to know what is the position. So we already know we have no indexes here, but we can calculate the position with the help of this counter variable. So while current node is not null, it other means that we, until or unless we reach to the end of this list, we will do this following process. And what is this process? That if the current node data is equal to the searched value, then we will return this position. For example, it is in position 1. Otherwise, increment the position, mean it will be position number 2, and for its correspondence we will move the current node to current node dot next, and we will again do this comparison until we reach the value. If we find the value, we will return its position, and if we reach the end of the list, or in other words current node is null, we will return null. It means the value has not been found. So here is a simulation. For example, you want to search 12 here. So how it will work? Current node is head, so head was always pointing towards this and we will not change this thing head, because head will always be pointing towards the first value. So current node is head, it means current node will also be pointing to the same value to which head is pointing, and we'll say position is 1. We know it is on the first position 5. While current dot node is not null, it means it will iterate this loop until it finds and returns some position, or if it doesn't find, it will reach this null. It will reach the end of the list. So while current node is not equal to null, and we know this is not equal to null because it's pointing towards 5, it's pointing towards the node, we will compare it. So current node dot data is equal to key. Current node dot data is 5 and key is 12. So it will not return the position because condition is not true. Position will be incremented. Position is now 2, and to correspond to this position, this current node will be moved here. So current node will now point to the address that is current node dot next. So current node dot next contains the address of the next node, and now current node will point to the address that is in fact the address of the second one. So current node will point to 19 now. So again we will check the condition. Current node is not null. So current node dot data is equal to key. We will compare. 19 is not equal to 12, so it will not return this position. It will increment the position to 3, and to correspond to this position, current node will move here. Again, condition is true, comparison is not true, position will get incremented, and afterwards the current node will move here, and still condition is true. Current node is not equal to key, so position will be incremented and current node will move forward. or in other words move next. Current node is not equal to null condition is true, but current node dot data is 12 is equal to key, that's also 12, so it is equal. So this condition is true and its body will be executed, it will return 5. And whenever we say return something, it means the algorithm is going to be n. So it is so every other statement will be neglected. Now, how to update a value? So here you know how to search a value, and to search a value we need to go through every value. So it is also in fact the algorithm to traverse the whole list. So we are not going to write a separate algorithm for this traversing or printing. Now how to update a value? Whenever you reach a value, you can just update by one statement that current node dot value is equal to the new value. For example, if I am here, I can write current node dot value is equal to 17. So it will be updated to 17. So it is just a constant time operation. And you know, searching, it's sequential search, so it takes order of n. The next problem is how to insert a value. Now here is how you control. See, to insert a value, you need two parameters. First, what is the value that is to be inserted, and second, at what position you want to insert a value. Maybe you want to insert at position number 1, maybe in the middle, maybe at the end. So this position is necessary as an argument. So you know, position starts from 1. So if an argument is there which says position is 0 or -1 or something like that, everything that is less than -1, so it will return null. This insert is not successful. Otherwise it will do the insertion, but for that insertion we have already checked the lower limit, so we will first check the upper limit. So here is where we are going to check the upper limit. So when we find, it is the same searching algorithm, very similar to that. So if we are going to find the current, if we are going to reach that position, it means that position is in fact in the limits of this list. So we are going to create a new node. Otherwise, if we reach at the end, and for example the position was 5 and we had just 4 or 3 elements in the list, so it will continue to compare every value until it reaches the last one, that is null. So it hasn't found in fact 5 because 5 wasn't there. It has only 3 or 4 values, so it will return null. So this is just the searching algorithm. After that, if you have checked the lower and upper bounds, then you can create a new node and you will assign the value to this new node, and then you will just check that you want to insert at beginning or in the middle or at the end. So this, if position is equal to 1, it means either the list is empty and you are going to put it in position number 1, or the list is not empty but you want to put it at position number 1, means you want to make it the head. So what will you do? You can do it by just these two statements. Otherwise, if you are going to insert in the middle of the list or at the end of the list, these two statements will be sufficient. So here is the iteration. Now you are given these two parameters, position equal to 0 and value is 10. So you know this is wrong. So if position is less than 1, it is 0, it will return null. So we all know it can happen. Now the second case, if position is 1, what will happen? You see here, if position is less than 1, return null. No, it is not the case. Current node is pointing towards head and current position is 1, while current node is not equal to null, it will reach that position. So current position is equal to this position because current position is 1 and we have to reach position number 1. So we are already there, so it will break. So current node is not null, it is pointing towards something. This condition is for the case when it iterates the whole loop and in fact the position is not there, that I have already explained to you. Now we will create a new node and we will assign this value 10 to this node, new node, and if position is equal to 1, it means you want to insert it at the beginning, so it means it will be the first node. So new node dot next will be the head. It means new node dot next, so it will point to the same node to which head is pointing, and head will point to this node, so it will make this one the first node of this algorithm, of this list. Say this was the case, you can rearrange and you see what can happen. So there is another example where you want to insert at the end or in the middle, so it is the same case, so we'll consider only one example. So position is 4 and we have to add the value of 10, so position is less than 1 and current node is equal to head, current position is equal to 1, while current node is not equal to null. It means this loop will iterate until it reaches the end. And what is it? If current position is equal to position, current position is 1, it has to reach position number 4. No, it is not the case. So it will increase this counter, current position will be 2 and current node will move forward. Still condition is true and there is not a match between 4 and 2, so current position will become 3 and current node is equal to current node dot next. Still the condition is true, current position is 3 and position is 4, so it's a mismatch, so it will increment the current position to 4 and current node will move forward. Condition is still true, it is not pointing to some null. And current position is 4, position is 4, so here is the match, it will break. It means we have reached where we want to insert a value. Now if current node is equal to null, then return null, it will not be executed. We will create a new node and we will assign this value 10. So this position is not 1 in fact, so position was 4, position is not 1, so it means we want to insert at middle or at the end, so this else portion will be executed. And else portion, new node dot next will be current node dot next. So current node not next will be assigned to as new node dot next. So new node dot next will be pointing towards the next node of current node. So it will be pointing towards this. Now we have to break this link. So this is called current node not next. So it will be pointing toward this node now. So hence we have first, second, third, fourth, and then fifth, and then sixth value. So we have inserted it. So we can do the same for the end as well. So it is the same procedure. So there is a question here. Sometimes it is my procedure to teach that there is a bug in the algorithm. You have to indicate this bug. So if you will indicate this bug, you will get some extra points. So it is just like an extra quiz, you can say. So whoever will find the bug in the algorithm, so there is a bug that is intentionally being put here. So you will, if you will indicate, I just give you a hint that you are suppose you are going to add a value at position number 1 and head is pointing towards null. So you just simulate it and just tell me what is the bug here. If it is, so if it is not, you can tell me. But I have also indicated you the hint so that you can find the bug easily if it is there. So this will be an unannounced quiz. Everyone who has watched this video will be able to know that this is a quiz, because it's just for extra marks. It is not a regular quiz. So there is a practice question for you. There is a function calls insert value, and insert was successful. How will the calling function know that the insert was successful? So maybe there is something else that is missing in this algorithm. So please find out the missing statements. It's just a practice question. It's just a small statement that is missing here. Just a very small statement. So you have to indicate. So it will give you a good insight of how algorithm works. Now the next thing is how to delete a value. So same, we have the we can have many cases that we want to delete the first element, or we want to delete any value from middle or at the end. So we have two cases here. So procedure is same, but to delete a value we need the value that is to be deleted. So as a parameter, that value will be passed. So we will delete this value if this value is present in the list. If this value is not present in the list, we will not delete it and will return false. False will mean that this value is not found. So here is how we find the value. It is the same searching algorithm that we have copy pasted here with a bit of alteration. So because we have another pointer here called previous node, so we are not just calculating the position, or we are not just pointing to the current node, we are also pointing to the head node, and that is required when you are going to delete a value. So it is not very difficult. Just add this one statement in your search one, that while current node is not equal to null, if current node dot data is equal to value, when if found is successful, then break. Otherwise, what will you do? You will increment the position, you will go to the next node and point it as a current node. But before doing that, before going to the next node, this node will be assigned to previous node, and then you will move forward. So you can save the status of a previous node with the help of another pointer here. So if current node is null, it means it reached the end of the list and didn't found, so return will be false. It means this value was not included, this value was not in the list. So but if it was not the case and previous node was null, it means, you see, initially previous node is null and current node is head. So if the value is found on position number 1, it means the value that is to be deleted, that's the head of the node. So its previous will be null. So previous node is null means that the value you are going to delete is in fact the head, means the top of the first value. So it will be controlled by just this one statement. Otherwise the other statement will do, and then we will return the current node, delete the current node. It means we will free the memory. So this memory location can be assigned to some other variable, and we will return true. It means delete was successful. I will simulate it with the help of an example. Suppose we are going to delete 5 here and you know it is the head of the node. It is the head. Previous node is equal to null. Current node is pointing to the same node to which head is pointing. Position is 1. Current node is not null. So current node dot data is equal to value. Current node dot data is 5 and value to be deleted is 5. So it will break. Current node is not null. So previous node is null because we are going to delete the first one. So the value of the previous node is pointing to null. So there is just one thing we will do. Head will be pointing. So see, we are going to delete this 5. So it means the first value in the list will be 19. So head must point to this 19. So head will be pointing to current node dot next, or you can say head dot next. It will be same. So now start of the list will be 19. So what to do with this 15? We will delete it. So memory will be free and we will return true. We have done that. So if this value is 12, for example, we are going to delete 12, and this is in fact the end of the list, or somewhere in the middle. So what will be the simulation? Previous node is null, current node is head, position is 1. We know the position of this current node is 1. It is in the first position. While current node is not equal to null, and current node is not equal to null, it means it hasn't yet reached the end of the list. So if current node dot data is equal to value, we all know that this value, this condition will be false until we reach this last one. So 5 is not equal to 12. So position will be incremented. and this current node, previous node will point to the same node to which current node is pointing, and current node will move forward. So now we have a state of previous node, means one before this current node, and again the condition is true, value is not matching, position will be incremented as 3, and previous node will also be incremented, mean it will move forward, and current node will also move forward. Condition is still true, value is not matching, 12 is not equal to 0, position will become 4, previous node and current node will move forward, current node is not equal to null, condition is true, this condition is false because 12 is not equal to 4, position will be incremented as 5, previous node and current node will be adjusted as well. Now condition is still true, but here is a match, 12 is equal to 12, we are going to break, we haven't reached the end of the strings, so it means we will not return false. Now previous is equal to null, no, previous is not null, it's pointing towards this node 4, so it means we will go to the else portion. And what is the else portion? See, we are going to delete this node, so it means 4 will point to null and this 12 will be vanished. So 4 will point to null now. So previous node dot next will be current node dot next. Current node dot next is null. So previous node dot next means previous node will now point to current node dot next. So it will bypass the current node. So if we have bypassed it, so this 12 cannot be accessed now. So why not to delete it and freeze the memory? Delete is successful, so we will return true. So here is how it works. So this was a very simple concept of linked list. It's not a very difficult concept, it's very easy. So here are some variations of linked list. They are called doubly linked list and they are called circular linked list, and there is another variation, we will discuss it. So what is in fact this doubly linked list? So in singly linked list, head is pointing to the first one, it's the same, and first one is pointing to second one, second is to third one, and if it is the last, it points to null. But it can you can only move in one direction. In doubly linked list, navigation is possible in both ways, you can move forward and backward. So for every node there is not just a pointer to the next location, it is a pointer to the previous location. So there is no previous than the first one, so previous of first one will point to null as next of last one was pointing to null, and previous of second one will point to first node, and previous of third will point to the second node. So it will be doubly linked list. It has some advantage as well as some disadvantage. The advantage is that you can navigate in both ways. The disadvantage is that you need one more extra location to store each node. So working is the same. You can search by the same algorithm because it will move next. So it is not a problem. Updation is very easy. Whenever you're going to insert an empty list, for example, there is nothing there and you are going to create a new node. So whenever you will create a new node, you will store the value, suppose 5 here, and there is only one node, so there is no previous, so it will be null, or in other words, this is null, for example, this pi, and its next will be pointing to null, and it is the only element in the list what is the first one. So head will also be pointing towards this one, head will point to this. So it is easy to insert. So I'm not writing complete algorithm because these are just 3 or 4 statements. You will create a node, and this new node dot value will be 5 or whatever it is. New node dot previous is null. New node dot next is null, and head is equal to this new node. So these are just 4 or 5 statements. So insertion is not a problem. It's just in an empty list is order of one operation. Order of one means constant time operation. So I'm not going to write a complete algorithm for this. I've already demonstrated it here. So this was the first case. So how will you insert in an empty list? Now suppose I have got this node and I want to insert it at this in the front of the list, a list which has got previously some elements, for example 3 elements here. I want to insert it in front. So what will be the algorithm, or what will be the statements or the steps? You will create a node and assign the value, and what will be next you will do that this is head is pointing toward this first one. So this new node dot next will be head dot next. So in fact this will be pointing to, sorry, I'm mistaken here. This first value will become the second value. So this new node dot next, it will be pointing to this head in the first value. So it will create a link towards this, but head dot previous is null because there was no initial value. Now head dot previous will be this new node. So it means and you will move this head, you will break this link, you will say head points to this new node now. So now this is the start of the list. You can move to the next one up to this null, means up to this last value, or if you navigate in reverse order, so you can reach this first one, this first value. So I have just changed what I have changed, new node dot next and head dot previous, and I've also changed head points to this new node, but this is still unassigned. So new node, or now head dot previous is null because it is going to the first element and its previous will be null. So in the same way, it is very easy. You can do it yourself now. How can you insert in the middle or at the end? The procedure is the same. You just play with these tools. You just change these values in a particular order, and similarly you will delete it. So for deletion, you first have to find that value, and then you are going to delete it. So these are very easy procedures, and in fact the same procedure that were discussed in singly linked list with a bit of variation, because you have to control the previous variable, this previous value also, otherwise everything is the same. Now there is another variation that is called a circular linked list. In circular linked list, there is what happens that the next of last value is not pointing to null, it is in fact pointing to the first one. So it creates a circle here. So circular linked list is a variation of linked list in which the first element points to the last element, in a sense that you can reach the last element, and the last element point to the first element. And both singly linked list and doubly linked list can be made into a circular linked list. So it is in fact a singly linked list that has been made as circular. So it is in fact a singly circular linked list in which the next pointer of the last node points to the first node, and that is all what you do. So nothing more. And in doubly linked list, the next pointer of the last node points to the first node, that is the same which we did for singly linked list, but the previous of the first node point to the last node. So what is the difference between singly linked list and doubly linked list? In singly linked list, we have to just alter, or we have to control the value of this next pointer, but in doubly linked list we are concerned with the values of both. So we are going to alter both if we are needed. So the rest of everything is same. So how can you know that which is the first one in both the cases? So head will be always be pointing towards the first element, and if any data, any node or in other words, current node dot next is head, so it means that is the last one. So you can indicate which is the last one still, and you can indicate which is the first one, so it will not be a problem. So operations are the same. You can search from here. So which was the condition in while statement for searching was while current node is not equal to null. So now you can say while current node dot next is not equal when it becomes equal to head, so it means that I have reached the last element. So you can control it. So these are just tools, and you are to play with these tools, and every operation is just like the previous operation, except that you control this next and previous variable pointers. So it is not a problem in fact. So same can be done for circular linked list with implementation of singly linked list and with a doubly linked list implementation. So summarizing all it, what are advantages of linked list? Linked list is in fact a true dynamic data structure, so it can truly grow and shrink at runtime, and you all, I think you are getting why I'm uttering the word true here. By allocating and deallocating memory, so there is no need to give initial size of linked list, and insertion and deletion of nodes are easier. These are just constant time operations. Unlike array, here we don't need to shift the elements after insertion, create a new and copy these and then insert. So in linked list we have to just update the address present in next or in the previous pointers of a node, and everything is done. And a size of linked list can be increased and decreased at runtime, so it means there is no memory wastage as well. So in case of array, there is a lot of memory wastage, we all know that. For example, we declare an array of size 10 and store only 6 elements, so 4 are just wasted. So there is no such problem in linked list, as memory is allocated only when it is required, but there are also some certain disadvantages of linked list. So more memory is required to store elements in linked list, I already told you, because in linked list you don't just store the memory, you are also storing the pointers. So if you are storing 10 elements, so it means you are not only storing 10 values, you are also storing 10 pointers. So it requires extra memory for itself. And elements or node traversal is difficult in linked list, because you are only bound to move in single linked list, for example, in only one direction, and there is no concept of index. That's another problem. This problem is in every variation of linked list. So we cannot randomly access an element as we do in array by index. And so for example, if you want to access a node at a position n, then you have to traverse all the nodes before it. So time required to access any node is very, very large. And another disadvantage, that reverse traversing is also very difficult. So in array you can say that first I will you can print the array from n to first element, I mean from upper to lower bound, but here it can be done, but it requires a lot of effort. In the case of doubly linked list it's easier, but in case of single linked list it's you can say it's a very evil work. It requires a lot of cost in terms of time. So here are just a summary of cost of operation with respect to time. Space is not concerned, my concern now. So in array you can access is very easy. So you can access in order of one time. Order of one means in constant time, but in single linked list or in doubly linked list you require order of n time in worst case. Search is the same as far as linear search is concerned, and if binary search is concerned, it cannot be performed on linked list, and it can be performed on arrays. So these are 2 plus points of arrays, but in insertion and deletion, singly linked list and doubly linked list have some plus point, because after searching you can delete in just constant time, and you can insert a value in a constant time, but in arrays you require order of n time to insert or delete, especially when you have to move and copy all the array. Now there is a practice question for you, that up to now we have just said that there is a linked list, and you all know how to insert a value, how to delete a value, how to read a value, how to update a value. Now suppose we want a special linked list, that whenever we insert a value, initially the list is empty, you insert first value, it is inserted, it's no problem. But when you insert second or third or any other value, it is inserted in a position such that it is, after inserting, it is greater than or equal to the value of the previous node but less than the value of the next node. So it means it's in an order, it's in ascending order. So such a single linked list is called an ordered linked list. So you have to just write an algorithm for its insert procedure. Other procedure will be same, searching procedure will be same, traversal procedure will be same, updation will be same, deletion will be same, but just insertion will be different, and you are required to write an algorithm for its insert procedure. It's easy, it's not very difficult. If you know the insert procedure of the previous ones, so it will not be a problem. So this lecture contains very comprehensive details and analysis of what linked list is. And second, it also contains some questions for you. At least 3 or 4 questions are there for you to solve, and if you solve these questions, if you give effort, so your insight in linked list will be very very high after this, inshallah ta'ala. So I hope you will do it in time, inshallah ta'ala. There is no time limit for it. In time means that right after watching the lecture you will do it, inshallah ta'ala. So hope that you are well, and we will meet in the next lecture, inshallah ta'ala. Allah Hafiz.